A very good day to Encik Ahmad Shafawi bin Abdullah. My name is Dishalan Analalaki Morgam and my metric number is 01DKM20F1087. My group members are Ezhilchelvam F1090, KIRIDHARA F1104, WARDINA SAFIYYAH F1086. We are from DKM4C and we are from Group 11. Today, we are here to present about our mini project, which is on soldering iron. Let's move on to the slides. First of all, let's look at the definition of reverse engineering process. Reverse engineering is the design process in which a product is analyzed or recreated using a physical part as a starting point. In practical terms, a reverse engineering project works backwards from the end product to determine the design and technology used in its design and development. The aim of reverse engineering is to develop an understanding of a product and its parts by applying in-depth analysis. Reverse engineering usually imitates and innovates a real sample or model. The surface model is constructed in reverse software and then input into CAD/CAM system for further editing and modifications. There are two samples. Sample 1 involves 3D profile measurements, data processing, CAD surface construction, shape modification, CAM regenerates CNC file, mold processing, molding, product duplication. The next sample is 3D profile, starts with the 3D profile measurement, data processing, CAD surface construction, shape modification, generate STL file layer by layer, rapid prototyping, molding, product, and then product duplication. Moving on to the next slide is the introduction to soldering iron. A soldering iron supplies the heat that melts the solder. It consists of a tip which you apply to the metal parts you want to solder together and an insulated handle so that you can hold the iron. Soldering is widely used in the electronics industry for electrical connection, such as joining copper to printed circuit boards. Soldering iron tips are made of a copper core plated with iron. The copper is used for heat transfer and the iron plating is used for durability. Next is the description of reverse engineering process. Let's look at the overview of the soldering iron. You can have a look at the front view, top view, side view, and all over the soldering iron. Next, Ezhilchelvam will continue the slides.
Hi, my name is Ezhilchelvam PONNUSAMY. Today I'm going to explain about the dismantling of soldering iron. We dismantle the soldering iron into 5 parts, which is the tip, the heater, the protective cover, screw 1 and screw 2. After we dismantle the parts of soldering iron, we measure the parts of soldering iron. First part we did is tip. We measure the length, the width, and the diameter of the tip. Moving on to heating core. We measure the length, the width, the inner diameter, and the outer diameter of the heating core. After that, we measure the width, the length of heater. After we're done with the heater, we measure the length and the width, inner diameter, and the outer diameter of the protective cover. Last but not least, we measure the length, the width, the diameter of screw 1 and screw 2. The exact measurement for these parts is stated on our report. Moving on to modeling using Autodesk Inventor. We use Autodesk Inventor to model the parts that we have taken measurement for. The first part is the tip, and the second part is the heating core. We did the modeling for the tip and the heating core using Autodesk Inventor. My friend will continue the rest of it. Thank you.
In the next part of 6.4, which is modeling in Autodesk Inventor, the heater and the protective cover of the soldering iron is remodeled using Autodesk Inventor. Finally, screw 1 and screw 2 in the soldering iron is modeled using Autodesk Inventor to get an output of 3D model of the soldering iron parts. Next, the next part we are going to look is overview of product. As you can see here, these two pictures are the actual pictures of soldering iron taken from the top view and the front view. The next two pictures you are seeing now is the output 3D model of soldering iron in Autodesk Inventor, which is taken from the top view and the front view. These are the top view and front view of the output 3D model of soldering iron, which is done using Autodesk Inventor. The next part we are going to see is difference in replicating and possible causes cannot to produce replicate. The first difference is in replicating is the actual color and the replicating color of soldering iron is not same as seen above. The possible causes for this difference is sometimes Autodesk Inventor may not have the same colors as the actual product's colors due to its software and more. Therefore, the nearest color matching to the actual product or better colors are chosen when replicating the product. The second difference in replicating is the measurements of 3D soldering iron model are not as same as the actual product. This is because when using Autodesk Inventor, it may be hard to put dimensions that have many decimal points. Thus, a round off number or a smaller decimal numbers are used as dimensions when replicating the product. The final difference in replicating is the 3D soldering iron is a bit smaller than the actual product. The reason that is justified for this difference is in Autodesk Inventor, we mainly use dimension in millimeters. This causes the 3D soldering iron to be a bit smaller than the actual product. These are some of the differences in replicating and their possible causes cannot to produce exact replicate.
It is difficult to recreate the soldering irons hitting exactly like the real thing. This is due to the heater's small size and dimensions, which is the necessitates the inclusion of components such as tiny magnets and heating coils. To design these elements, more practice is needed. As a result, the heater is the most difficult component to duplicate. Now, let's talk about the conclusion. We as a group learn about the reverse engineering process in the design process. Reverse engineering is defined as a process that works backward from the end product to determine the design and technology used in its design and development. We are instructed by our lecturer to use Autodesk Inventor as our software to create the 3D design of the product. In addition, we also have accurately measure the component of the product. We identified there are 6 components in this product after we inspected it. The parts were tip, 2 types of screw, the protective cover, the heater, and the heating core. We took the measurement. We also gained understanding of the improvement in terms of the environment and sustainability of the product, which is soldering iron. In a conclusion, we acquire a lot of knowledge about the reverse engineering process by carrying out this mini project. Drawing, documentation. When the parts of soldering iron are sketched and replicated in 3D models, the assembling process starts. Firstly, make sure all the parts are placed in the same drawing place or plane. They join the part together. The tip goes in the top of the heating core. Only little part of the tip is shown outwards. The heater goes into the protective cover fully. The heating core is fit to the protective cover. Then screw 1 is fit into the hole at the heating core and screw 2 is fit into the hole at protective cover. Finally, the color for the tip. Heating core, heater, protective cover and screw are chosen. The assembly process is done. The 3D model of soldering can be seen and overview from top view, side view and front view as shown in the picture above.